Sometimes the best way to deal with these is just to get in there and try something. So here's another example. This happens to be at the bottom of page 565. And it just looks like this. Sine squared theta minus 1 over tangent theta sine theta minus tangent equals sine theta plus 1 over tangent theta. And remember that your goal here is to make the two sides look alike. So I look at them and I go, which one looks more complicated? To me, this one looks more complicated. And so I start looking at it and I think, okay, is there anything that I can do to this? And since there are subtraction signs in there, I start thinking about factoring. And on the top, this is a difference of squares because this has a square root and this has a square root. And if you'll remember back to your factoring days, if things have square roots on each side and a subtraction symbol, then the way you factor them is you'll end up with two sets of parentheses, the square root of the first term, a plus and a minus, and the square root of the last term. So that's what the top would be if it were factored, and we're going in the right direction because this is one of the terms on the right side that we're trying to get. Now on the bottom I have a subtraction, and I also have a like term in both parts of that expression. So if I pull out a tangent, I have a sine left and a 1 left because tangent goes into itself one time. So I can cancel the things that are alike, and I am now left on the left with the same thing that I have on the right side. So they match each other, and that's our goal, is just to make the two things match.